Hello, in this video we're going to look at how we can use the cloud for scaling and performance. Let's get into it. Say what? Scaling? Yeah, there's two types of scaling. Scaling up and down and scaling in and out. Of course we can't scale without some level of data persistence. We're going to talk about that next. Scaling also gives us a bit of high availability. And to achieve scaling efficiently, we need short-lived servers. This playlist is based on a book you can get from Amazon now. If you want to know more about how to become a DevOps contractor, check out the link on screen. It's also in the description below. Scaling up and down. Essentially what this means is when we scale up, we have the same server, but we put more stuff in it. We allocate more CPUs or more memory so that it can handle a bigger load. Scaling down, of course, is the opposite, where we take those resources away and return the instance back to having the same CPUs and memory it had before. The other way of scaling is in and out. Scaling out is where we have the same specification of server and we just have more of them. 2, 3, 4. Okay, what? And then scaling back in again. 4, 3, 2, 1. Within the cloud, we can do this in an automated nature. More about how to build a server later, but for scaling out, if we have an auto-scaling group, we can set up alarms and alerts on those so that we know when we're under strain. When the system receives an action request, we can then create more servers, within our defined parameters of course. We don't want to spend too much money after all. Then similarly, those same statistics can drive alerts that drive actions to then scale back down again, so that we can then go back to an idle state. Scaling up and scaling down is quite simple. However, we have shared data. So quite often a 3-tiered application is split into those 3 tiers precisely so we can scale it. What do I mean by that? Well, if your application has any level of shared data, then you don't want that on your server. Let me give you an example. In terms of a WordPress site, most of the data is stored in a database. And on many installations I see they're quite small. So you've got the web server and the database on the same virtual server. If we then scale that up to 2, we then have 2 web servers, but we also have 2 databases. It's not likely that you'll want a duplication of the data. What if somebody logs into one of the servers and then somebody else creates an account on the other server? Now all of a sudden you've got a split brain scenario where the databases hold different data. So in order to scale efficiently, we need to keep that persistent data on a different layer, hence the 3-layer architecture. The web front end, usually static content, pictures and the like, the application middleware, the stuff that does the customization, and then a back-end database. We can scale databases across multiple servers, but that takes a little bit more finesse. Likewise, for any data that's on the servers, like logs, we need to get those logs saved off the server in the event of a scaling in event. If your web service does use sessions of any kind, i.e. users logging in, then we do need to make sure that that's accessible to all the servers. There's an example in my book that says when I was working at AXA, they had 2 servers. Great. The load was balanced between the 2. However, when the other server went offline during scheduled upgrades, those users would get booted out and they'd have to log in again on the other server. It took us a while to work out why this was happening. It's due to the session data. It was being stored in a shared database, all good there. However, it was being encrypted with a server key, and only the server that you logged into knew how to decrypt that data. When you were looking at that session data, if you happened to be on the other server, it didn't think you were logged in because it didn't have access to that session data. The fix here was easy. We just had a shared encryption key across both servers. Scaling can fix some of the high availability issues. After all, if you've got 6 servers and 1 fails, then we've still got 5 servers to serve the load. Hopefully the customers won't notice. This is what we mean by high availability. Disaster recovery, on the other hand, can be a different kettle of fish. In terms of cloud providers, they normally provide multiple data centers. In London, for instance, AWS has 3 data centers. They call them availability zones. These are 3 physical buildings, might be more, that have separate power, redundant power as well, so at least 2 lines coming in, redundant network, and other than that are quite isolated on their own. This means having a failure in, say, Zone A won't have an impact on stuff in Zone B. That is, of course, if you've designed your application correctly. As mentioned in my previous example, you could have a configuration where there's an inheritance of data that's not really planned out. By fixing those, then we can have high availability and disaster recovery. If you're in IT, you'll probably be aware of the server that no one wants to touch. They don't want to reboot it, they don't want to upgrade it, they don't do anything to it, because if it goes down, it's a critical infrastructure and can cause considerable pain. In an ideal world, everyone would have a project to take that delicate server and then upgrade it with a new design where we do have high availability. The ultimate in automation when we're scaling out is for it all to be automatic. This means that when we want a new server, a new one appears, all the correct configuration, configures itself, and then when it's done its job, it disappears again. I've done a whole talk on how to create servers. Of course, you might know a slightly different way of doing it. Docker containers follow this very principle. They're designed to be spun up, brought into existence, run their one task that they do really well, and then shut down again afterwards. From running Docker containers, they spin up even faster than virtual machines do. If you want a great example of something that exists, does a specific job and then disappears again, check out Mr. Meeksies on Rick and Morty. A few years ago I did a presentation on how I use Puppet to create short-lived servers. The link's around here somewhere. The next chapter in the book is exploring the software development lifecycle. If you want to get notification of when that video is up online, subscribe to my channel, and I'll see you soon.